Good morning, everyone. And I know it's Saturday morning. You probably have a lot of better things to do, so I really appreciate you coming out and listening a little bit about water quality here in the Valley. I do want to point out a few people. Ed Pack is a member of our board, elected by you and representing you on our board. And we also have Franz de Klotz. There he is there in the back. And we have lots of volunteers that are volunteering their time here this morning to answer your questions and provide additional information. I've had the opportunity to talk at a lot of functions outside of California. Everybody wants to know how California is dealing with all the regulations. We are usually the leaders in drinking water regulations and other regulations. So they always like to hear how we're dealing with it. So it's nice to have the opportunity. And the district here is very proactive in what needs to be done to comply with drinking water regulations and to provide the best quality water service at the best price. So because of that, they are very progressive. We get to get out there in front and learn a lot about what needs to be done and try to forecast what we need to do in the future. So we're going to talk a little bit about general water quality first. And let's go ahead and get started. So where's the source of our tap water? We have a large watershed with these mountains. And over hundreds, if not thousands of years, that precipitation, the melting snow, has drained into this valley and filled up our groundwater basin, the aquifer. Basically, it's a big bedrock bowl filled with sediments of all different sizes. And in between those sediment particles is the water. And that's an aquifer. And that's our huge resource for providing our water, most of our water resources here in the valley. The water comes in naturally, as I described, and it also comes in from imported supplies. In the East Valley, we've had Colorado River water flow into the East Valley naturally for eons. It would come in, and then it would go to the Delta, and then it would come into the valley. So the Colorado River has been an important part of our water resources here in the Coachella Valley. In addition, we are importing water through contracts that we negotiate for and pay a lot of money for to bring Colorado River water into the West Valley and to the East Valley through the Coachella Canal. So that Colorado River water is an important part of our water supply portfolio. When that water hits the ground, it percolates through hundreds of feet of sand particles. It's one of the best filters there are. And the only thing in that surface water that doesn't make it potable are microorganisms. So those bacteria gets filtered out in that slow sand filtration. So it leaves water that meets drinking water standards naturally, without chemicals, without disinfection. So that's a good thing. It's a great way to bring the water into the valley. The valley is well suited for where we are putting the water in. We put the water into the ground in the West Valley where all the windmills are. That's where all that blow sand is, where that fine sand is, and it allows excellent percolation rates. So it's a great location, it's well situated, and we don't have a lot of contaminating activities up there. It's pretty much just natural area. We don't have golf courses in that part. We don't have other potential industries, anything that could leave behind pollutants that could go into the ground. So that's a great way that we have located those recharge facilities to protect water quality. A little bit of surface water is used directly in the Palm Springs area through the Desert Water Agency. The rest is all from the groundwater resource. And here's in the bottom right is a photo of the recharge ponds up there that I described in the Whitewater area back in the early 70s. And what those dikes would do would be just to slow the water down and let it soak into the ground. In 1918, the first board of directors, the first action they took was to build some silt dams up there to catch that natural water and soak it into the ground. 1918, they were thinking about groundwater resources in this valley. It's remarkable. And on the picture on the left is the ponds, what they look like now. It's over 600 acres of facilities that we use to get that water into the ground. On an average year, we're talking about $50 million worth of water that we're importing and putting into the ground to ensure we can meet your needs. Here's a facility down in the East Valley, a little bit east of the Lake Kauai. And that facility went into operation in 2009. It's our newest recharge facility. It's putting in about 35,000 acre-feet of water into the ground each year. An acre-foot of water is about the amount of water 2 homes would use in a year's period. And as a result of this facility down in the East Valley, we are seeing water levels rising there. And in that area, you probably saw that photo of the water rising above the early settlers' heads. That was artesian flowing water. Naturally, the settlers would punch holes in the ground, and it was under pressure, artesian pressure, and would rise above the ground without any pumping. Since this recharge facility went into operation, and some of our other water conservation measures, we are now seeing those artesian pressures returning to that East Valley. And that's very important because it protects our water quality. By pressurizing the lower basin, where we're extracting the water, you're preventing that natural saline water in the top from going down into the groundwater. So pressurizing that basin is very important for protecting water quality. In delivering our water, one of the key things we do is find out where to drill the wells. And we have really variable water quality here due to naturally occurring sediment. Water likes to dissolve things. It's the universal solvent. So as soon as it forms in the atmosphere, it's dissolving carbon dioxide, becomes bicarbonate in the water. When it hits the earth, it's dissolving the sediments. It's in your glass, it's dissolving the glass. It's the universal solvent. It wants to become stable by dissolving these minerals into it. So it does get some of those sediments, minerals, calcium, magnesium, potassium, things that we need are all in that water in low levels, very low levels, because of what it does. So we need to locate, we have areas that have high fluoride levels in the valley, and we have areas that have high salinity naturally. So we do these monitoring wells to find the best places to drill our wells. And when we drill a well, we use these casings that have the screened areas, and that's how the water gets into the well. And just like it naturally filters the sediments in the aquifer, filter the bacteria, we use sand particles to keep the sand out of the well. So we size these particles just right size so it doesn't go through the screens, but it traps the sand particles. So those are engineered in size to do that function, to keep the sand, so only the water can pass through the screens into the well. So that's a typical well. We drill very deep wells because it's better water quality. So it protects from what might happen at the surface. We have very deep seals. Instead of a 50-foot seal as required by the state, we'll do seals as much as 800 feet to provide better protection for the water quality. We have dozens of state-certified operators and distribution folks and treatment operators that are making sure that that water meets those standards, making sure that when we convey it through our hundreds of miles of pipelines, that it maintains that high quality. We have distribution reservoirs you'll see on the hillsides. You may have noticed some of them, about 60 of them. That's an important part of our system, and it provides pressure if we have an emergency, if the power goes out. That keeps our lines pressure because they're elevated. That's an important water quality feature. You want those pipes pressurized because when they lose pressure, things can enter into them. Bacteria, things like that. So keeping the system pressurized through these elevated storage reservoirs is a good water quality feature.